Shouts to all my lost boys, we rowdy. Shouts to all my lost boys. Shouts to all my lost boys. Shouts to all my lost boys. Shouts to all my lost boys, we rowdy. Shouts to all my lost boys.
So this is the chemistry of fireworks. Here's some information about the chemistry of colors in fireworks. So the colors in fireworks are generated by pyrotechnic stars, which produce colored light when ignited. The stars contain 5 basic ingredients. Color-producing compounds. These are specific compounds which produce an intense color when burned. Some of the commonly listed color-producing compounds, or the commonly used color-producing compounds, are listed up on the right, and generally they tend to be metal salts. Fuel allows the star to burn. Gunpowder, which contains a mix of potassium, nitrate, sulfur, and charcoal, is usually used for this. An oxidizer, which is usually nitrates, chlorates, or percolates, required to provide oxygen for the combustion of the fuel. The binder holds the mixture together, and the most commonly used binder is a type of starch called dextrin, which is dampened with water, and a chlorine donor. These can help strengthen some colors, and sometimes the oxidizer can also act as the chlorine donor. And then there's a list of different metal salts that produce different colors in fireworks.
The aerial shell is the popular firework device used in public displays to produce bursts of color high in the air, often accompanied by a thundering boom. Explosions of several aerial shells are shown on the cover, or there's a video next that shows several of them. The multiple break shell illustrated at left is a red and blue report where it's a 3-part aerial shell. This is the most complex item of this type, producing a succession of bursts when fired into the sky. These devices are fired from steel or heavy cardboard mortars buried in the ground and commonly range from 2 to 8 inches in diameter, although 10 to 12 and even 24-inch shells are produced commercially. The shell is lowered into the mortar with a long, quick burning fuse extending out of the tube. The end of the fuse is ignited. When the burning fuse reaches the top of the device, it ignites another fuse. A slow burning delay fuse that will later ignite the first of the 3 main charges in itself continues burning rapidly toward the black powder repellent at the bottom of the firework, which is the part that shoots up the shells itself. The black powder ignites to produce gases that project it, and the delay fuse then reaches the main charge in the first compartment, which produces the red star. Then the next burst produces the blue part, and then the last is the flash and the sound, which happens after it's lit.
This slide is about firework bangs, crackles, and whistles. The colors of fireworks get a lot of attention when it comes to explaining the chemistry behind them. However, there's also a lot of chemistry behind the assorted noises that fireworks make. Here, there's a brief look at what causes the bangs, crackles, and whistles in firework displays. Firework bangs are produced by the ignition of an explosive mixture of compounds, usually an oxidizer, potassium chlorate or potassium perchlorate, sulfur, and aluminium. They produce a flash of light and a loud bang, so are often referred to as flash and sound mixtures. These are compacted combined gunpowder can also produce a large bang. Crackling fireworks were originally made using lead tetroxide mixed with magnesium and aluminium magnesium alloy. The mixture is divided into small granules, and their rapid combustion produces the crackling effect. Due to lead's toxicity, bismuth compounds are now more commonly used. Whistling fireworks owe their sound to aromatic organic compounds such as gallic acid, sodium salicylate, potassium benzoate, and picric acid. These are mixed with oxidizers, for example, potassium perchlorate, and tightly packed into a tube. Small explosions caused by the aromatic compounds lead to oscillations in the gases created by the burning mixture. This creates a standing wave in the tube, producing a whistling effect. And that's it for the chemistry of fireworks.